necessarily would have stayed through all of that conversation. But here we go. System of equations, augmented matrix, and what was I doing in the very first step? Solving? Kind of? Pause. Yesterday. REF, right? That's the goal. Section 7.32? Whatever section it was in chapter 7. REF. We did this systems of equations, and I asked you guys what was the very first thing we would do with systems of equations to get towards REF. Somehow deal with the first two and try to get rid of x, right? And then we would go again. We would use 2 and 3 and get rid of x. And then what would we try to do? Take 4 and 5 to get rid of y. And if it's a three-dimensional system, what should we then be able to solve for? Z. And then from z, find y, and from z and y, find x. So, what have I done? I've kept this guy because he's already good with an x and a y and a z and a number. I have my first equation in my row echelon form. I didn't need to change him. But what did I need to get rid of for my next step? I needed to get rid of x. And how do I get rid of x? I get a 0. And we talked just briefly yesterday, the idea behind how if we were a computer, we wouldn't need to be creative. We wouldn't need to see, oh, hey, add those two, it's 0. Because if you add those two, they're not always 0, right? If you multiply this one by that one and this one by that one, they will always be, right? 3 times -4 and -4 times 3, they will match. Put it in opposite sign, they will always get 0. But we're not computers, so I'm letting you be creative. That's a good thing. And I'm saying, do you guys see how if we add those two, we get 0? But with equations, don't we have to keep them balanced? Chemistry, math, same thing. We have to keep everything balanced, right? So if we randomly go adding these two together, what else do we have to do? Add the rest, right? So when I say row 1 plus row 2, we're adding the two equations together, and where am I putting them? In row 2. Why? Because I need to go ahead and get not just a 1x, but also a 1y. Did we finish this off yesterday? 0, -1, 2, 2. What are we doing today? A lot of mental math. What do I need you guys to be doing with me? Mental math, so that if I make a mistake, sound good? Or if you make a mistake, yes, in a gracious, speak the truth in love way. Thank you. Okay, going on. Sorry, there's a bug. I'm going to squish him. We'll just let him be. Guys, question. Do I need a 0 anywhere else besides here to get towards REF? Where else do I need a 0? I need a 0 here. So he's not allowed to have an x, and he's not allowed to have an x? Okay, so be creative. How could I get rid of the 2? Multiply row 2 by 2? The name of the game is elimination, like we covered last section. What's hard is that we're dealing with all kinds of numbers in rows. We talked about battleship yesterday. But they're really just doing our systematic approach. We're doing equation 1, equation 2, get rid of the x's. We're doing the next step, equation 2, equation 3, get rid of the x's. That's what we're doing. We're just showing the little baby formula that's getting us there. So what happens when we do 2 times -1 plus 2? 0. Could you be writing all these baby facts off to the side? Yes. Would it be safe? Yes. But would your work be messy? Yes. Hopefully by honors pre-cal we can do at least a little bit of mental math, yeah? Okay, but we're keeping each other honest. That's why collaboration is key. So what's 2 times 3? Plus 0. Can you guys keep going? 2 times -1. 2 times -3. Go back. What mistake did I make? Good. 2 times -1. If you get going too fast, remember, mistakes can happen. -2 minus 4 is -6. But was I good here? -6 plus 6? Got it. Got it. Now, I don't want to assume that everyone is totally tracking with the mental math. So what could you do? You could, over here to the side, you could actually set up a little baby system on its own. And you could go ahead and do, hey, I'm going to do R1 plus R2 for the first fact. I'm going to actually do that off to the side. And you could get 0, -1, 2, positive 2. You could get this and then go put it in, right? You could do 2 times R2 plus R3. And you could say I'm going to take all of R2 and multiply it by 2, multiply by 2, multiply by 2, multiply by 2, and then take R3 and write it down. Could you do this? Yeah, and what'd you get? 0, 6, negative 6, 0. Yes. Will it take extra time? Yes, but it might be worth it for some of your brains that are like, I can't do all the numbers all at once. Okay? Do what you need to do. It's okay. But pause. How are we doing with the first step of REF, which is eliminating the x's in the bottom 2 equations? Remember, this first whole column is x variables, right? Is it a's or is it x's? I'm sorry, I'm saying x's. Are they a's? They're x's. Okay. What's the time to do now? 1x minus 4y plus 3z equals 5. We don't mind him. But what do I want here? 1y. But what do I have? A negative. I know, but it's the system. We don't mind the first equation, so rewrite him. The second equation, he's almost perfect, but do you remember we would always get 1x, 1y, 1z? I need a 1y without changing this 0. The only way to do it, just a heads up, and we'll write strategies in future sections where we're getting a little more technical, is to multiply everything by a negative. The 0 will still be a 0, and he'll be a positive 1. The 0 will still be a 0. And he'll be a positive 1. So let's just do negative R2 into R2. Does that sound good? Now here's the struggle. Am I talking about the original R? No. So for a computer, I'd actually have to tell it like an R4. Does that make sense? I'd have to reference the new equation that is there. But that's okay. For our purposes, we know we're looking in who is in the previous R2 spot. We won't go going R4 and R5 and R6 and eh. So what happens when I multiply 0 by a negative? 0. Negative 1. By a negative, 2 by a negative, 2 by a negative. Are we good, guys? I have my 1x minus 4y plus 3z equals 5. That's a great first equation for REF. I have a 1y minus 2z equals negative 2. A great second equation for my, look at that rain, listen to that rain, for my REF. But what do I need down here? I need a 0, 0? Some of you are thinking identity matrix. Some of you are thinking, oh, I see. Get 1s and get 0s below. That's exactly what we're doing. Some of you just need to think about section 7.3, 7.2, wherever it happened, where we said, hey, the bottom row, we don't want an x and we don't want a y, right? R2 plus 1/3. Yeah, I think you're looking, are you looking back here, Kyle? No. If we do R2, negative 1 plus 1/3 of 6. Oh. I'm not sure if we want to go like working with different terms, because remember, elimination uses whole equations, whole lines together. But let's keep thinking. Multiply what by 6, Adam? The new R2 by negative 6. Okay, so we could do that. We could separate these. Okay, let's go down. Now we want a 0. So we could do negative 6 R2 plus R3. Yeah. But if we divide by 6, what's still there? A 1y. Ultimately, do we want a 1y and a 1y for our REF? Well, then it'd be negative 1. Don't we want a 0, though? If we add it to. Most people, Kyle, I like your creativity and you're thinking fractions to get rid of the 6 and make it a 1. It's easier just to multiply something else by a whole number to subtract than to try going into fraction. Because remember, once you introduce a fraction, you're going to have to multiply that fraction everywhere, and it's not always pretty. Does that make sense? So if we can avoid it, we will. Do we mind the first equation? Do we mind the second equation? How about that third equation? What's negative 6 times 0 plus 0? What's negative 6 times 1 plus 6? Let me give you a second, because I go kind of fast. Can you guys finish off the row for me? Multiplying whatever number is in the R2 spot and adding it to the R3 spot, the corresponding R3 spot. Now remember, this is only section 8.1 in this chapter, right? We're doing a lot of exploration, a lot of discovery. We'll write down steps, procedures, tips and tricks to follow a little bit later. Yeah, but.
So when we break down the R2 and R3, that's the new R2 equation?
Yeah, the one from right above. Does that make sense? And the nice thing is with elimination, we really just need to have a whole equation with the whole equation. It doesn't actually matter which one we're taking because we're not computers. If we were computers, we have to be so much more precise. But we're just working on the thinking behind the programming. What'd you guys get for the next one? 6? Ooh, I heard a positive 12 and a negative 12. Let's check both of them. Ready? Negative 6 times negative 2 is positive 12. Minus 6 is positive 6. I agree. Negative 6 times negative 2 is positive 12 plus 0 is a positive 12. Are we good? Okay. Are we done? 1. Oh, is it as easy as that? I like it. So let's go ahead. I'm sorry, I should have been in row 3. Let's just do 1/6. So Kyle, here's where that 1/6 is completely appropriate. Because we can multiply 0 by 1/6, 0 by 1/6, 6 by 1/6. I wanted a 1 there. And 12 by 1/6. Show off to me that you know how to use your calculators. I want you to throw the original matrix into your matrix menu. Remember, edit. The original one. And then I want you to do REF to it, and see if you end in the same place. So we're practicing what we saw yesterday. Do any groups not have a calculator at all? Kim and Austin. Oh, Austin, you have one? Perfect. Remember, if you don't have one, peek on with someone else. Yeah, because we were going to do RREF, the whole identity, but then I was like, oh, that's a lot of work. Let's start with where we started with in equations with REF only. And we're going to build to RREF on the next slide. Gavin asked a great question. He was like, wait a minute, are we just trying to do 1s and 0s below? He was like, wait, that identity thing, we liked that. And I reminded him, we're starting off slow. Kyle and Aiden, make sure to show Robbie what's going on. Just to make sure, Robbie, that you remember how to put it all in. Just double check our REF. Is it matching? How's it going, Adam? Just REF. Just REF, right? Do you guys want to try RREF? I took my REF, I made him a system like we've seen before, and I said back substitute time, right, Robbie? Back substitute time. RREF, it works? What's different about their REF and our REF? Did anybody get a different version of REF? Okay. Let me know. What was their version of REF? 1, 0. And then? Two. Ooh. This begs a great question. I know I'm going to zoom out, but you guys have all the work on your page. Some of you are like, great, we were wrong. 30 more seconds if you guys need to ask each other any questions on the calculators. I see some good collaboration. I'll wait to talk for 30 more seconds. Make sure everyone's good. Good. Check in. Is it working okay? Oh, you have the big old huge one still? Okay, I see most groups almost there. Oh yeah, they found a quick input error. If you put like a negative in the wrong place or a number in the wrong place, the computer doesn't know you put it in wrong. Good, good. You can use the word order too, Austin. Nice thing is when you guys get into homework for section 8.1, the directions will be very specific.
Oh, so they'll tell you which one.
It will say, get into row echelon form, get into reduced row echelon form. All right, guys, let's go ahead and bring attention back up here to the front. I think we're almost close. Yeah, Austin, feel free. You guys can keep on chatting. I'm just going to go ahead and try to keep it quiet. We have one more group still trying to figure out the calculator, but for the rest of you guys, we're actually not wondering how to use the calculator. We're wondering how they got a different REF. Can you guys look at this? 1, 0, negative 2, 3. Does that match up with anything? 1, 0, negative 2, 3. 1, 0, negative 2, 3. How'd they get that? Not there. He has a 0, but wait. Divide by 2, divide by, see it? Jason saw it. Divide everything by 2. Wait a minute. Maybe whoever programmed the calculator, I had forgotten until right now, but we've seen this in years past. Whoever programmed the calculator, guess where they told the calculator to take the first equation from? The bottom. Why? Don't ask me. There might be some, maybe it was easier to program that way. We're taking from the top because we're used to stealing the top equation for the beginning of REF. Where are they stealing from? The bottom. But wait. They didn't write 2. Well, yeah, they shouldn't write 2. What does REF need to start with? A 1. And how do we always get a 1? Just divide. How do we get a 0? Multiply by the opposite and add. Do you guys notice that there were some patterns in what we were doing? If we ever wanted a 1, we would divide. If they wanted a 1, they divided by the number they wanted to get rid of. But if you want a 0, you have to do an addition that cancels out. You have to do an addition that cancels out. Does that make sense a little bit? Wait a minute. We didn't divide here to get a 1, didn't we? Ooh, we just wrote it because we're creative. We're not a computer. We wrote it multiplying by negative 1. Okay, so long story short, were they off? No. And if we had started with the bottom row, guess what REF we would have gotten? Same thing. So do your REFs have to match? It depends on which equation you choose to put first. The numbers might be different, but here's the question. When you did REF, did you get 722? Yes. So here's the question. Does every matrix only have one row echelon form? No. But does it have a unique solution? Yes. Well, if only one solution exists. Remember, there could be infinitely many, and then the calculator can't do it for us, and we have to use our logic. Gavin, go. Oh, we would have had to solve the system a different way. So if we had used this as our launching point, remember we used the first equation as our launching point and kept using it like over and over, and it determined what the second equation was. We used that over and over. It determined what the third equation was. So everything was built on us starting with the first. If you start with a different equation as your first, the numbers will just be different, but the equivalence is still there.
So like I found where the first one, how that related to one of those. And same with the third, but I couldn't find the same.
Oh, it's because there would have been some addition multiplication that would have made that 1.25. No, and you actually don't need to find any of them per se. You can just trust that the calculator programming is getting a valid REF. You're just getting a different one. And so the book might possibly say like, hey, get row echelon form, and you get one row echelon, they get another. But if you test them both, as long as they go the same direction, you're good. Does that make sense? And the nice thing is for us, aren't we all doing the same system? Remember we talked about this? There are so many different approaches to systems, and if we're all doing it a different way and you get it wrong, how will we know where you went wrong? Gavin, the nice thing is we're all going to be doing it together. How? establishing the first and building from him. Does that make sense? But if you want to be able to check with your calculator, REF, what would you actually have to change or adjust? Starting with the, yeah, Kyle's like flip it on end. Yeah, start with the bottom instead of the top. I know, it's kind of weird. Yeah. Does that sound good? Okay. So, guys, to be honest, I've already told you all about this guy. We've even done him in our calculator. We just haven't actually written about him yet. So let's write about him. Reduced row echelon form. Not just getting ones in the main diagonal and zeros below, but getting ones in the main diagonal, zeros below and above. Oh, what's the name of that special matrix? Ones in the main, zeros above and below? Identity. And now that Kyle's back, I'll give the shout out one more time. Remember yesterday he was like, wait, so the identity is what we want to get when we're solving a system? It's perfect. It's exactly what we want. So why didn't we do RREF on the last page? It's going to take twice as much work. Not twice as much. We just have twice as many zeros to get. But that's okay. We can do it. And like you saw yesterday, it's worth it to get all the way down to RREF because your solutions are there, ready for you to answer. Gauss. Ooh, he's a mathematician. Gaussian elimination, that's REF. So what's different with reduced row echelon form as far as its name? They're giving me a shout out to two guys, Gauss and Jordan. Okay, fine. We'll do a shout out to both. Gauss was the REF, Gauss Jordan, the reduced row echelon form. How would you guys fill in the dot, dot, dot? Keep simplifying until you get what? The identity. Is that cool? And as soon as you have the identity, guess what? You have your solutions. If there's only one unique solution, or we get something we'll have to analyze and go a little deeper in if there's infinitely many. Remember, let Z equal A. Ooh. Sometimes there's more than one answer. Yeah?
I'm sure we'll get to it, but the bottom one would be 0, 0, like 0, 0, A, 0, or 1, 0, A.
If it's 0, 0, like say it was a two variable system, yeah? If you got 0, 0, that's bad because your variables all went away, right? If you have 0, 0 number, is 0x plus 0y able to equal a number? So what would that be? An inconsistent system that has no solution. But what if you get 0, 0, 0? It's true. Let z equal a. Oh, z wouldn't be in here. Let y equal a. Y equals a. Oh. I see what you're saying. You wouldn't be putting 1 and a in your matrix because your matrix properly would be 0, 0, 0. But in your analysis of what the matrix gave you, you would say, oh, which means y equals a. Does that make sense? Okay. Guys, I'm going to show you the system. Is that okay? The system. What if you have numbers everywhere? Numbers everywhere, everywhere. Ooh, remember the numbers? I erased it from the front board. There's new stuff there now. Calculus, ignore. But remember, that's the first row, first column, first row, second column, second row, first. Remember the notation? Cool. Here's what you would want to aim for first. Now, I can't tell you necessarily. I could tell a computer. I could tell you, but it actually makes it harder on you because you're a creative being and you don't have all the computing or the speed of a computer. So pause. I'm just going to tell you what you want. You want to get a 1 here first. You want to get a 1 here first. We'll leave this guy completely alone. This can be solid, it can be dotted, it can be whatever you want it to be. Remember, it's separating variables from constants, right? Okay. You're going to get a 1 first. How are you going to get a 1? Wait, didn't we just say a second ago? We need to get 1s and 0s. Ooh, binary code, computer programming? Stop. Okay, sorry. Some of you know what that means, some of you don't. We need to get a 1. How did we get 1s a second ago in the example? Did we add or did we divide? So couldn't we do 1 over whoever that guy is? And that'll always give us a 1. Now, do I want you to memorize, okay, I better take A12 and divide it by A11. I better take B and divide it by A11. I don't want you to memorize that. I just want you to understand to get the 1, we're going to have to divide. And that's something we could tell a computer to every time. Well, what if a 1's already there? Well, if the computer divides by 1, we're still good. And remember, computers can do all kinds of stuff fast. We could tell it divide by the constant, the coefficient, I should say, in that first spot, and we'll always get a 1. Now, some of you might be like, oh, sweet, let's get another 1. It's not going to work without going into too much detail. So let me show you where you need to go next. You'll keep this guy. This guy will be totally fine. We're leaving him for now, but we're going to now aim to get a 0. And that's what we were doing a second ago. And that's actually what we were doing in Chapter 7 before we even talked about matrices and we were dealing with equations. We still are, but remember, they're hidden in a matrix. Now, how do we get zeros? Divide or add? Okay, now let's think about this. If we just got a 1, how are we? Don't we just need? No, dividing, we'll just get a 1 again. I don't want a 1, I want a 0. I'm going to need to add to row 2. And who's in row 2? This guy. But what can I do to this 1 to make it match and be opposite? Can't I multiply the opposite by row 1 every time? Now, once again, I don't want you to be memorizing unless you need to. Oh, stink. All right, so whatever's in the second column, first row. But this is a formula you can, or a pattern you can follow. Because if I go ahead and multiply the top by the opposite and then add, oh, do you guys see it's going to get really messy if I try to actually keep making a formula for it? Because you're going to have to multiply negative A21 by A12 over, can we just do a dot? Not super proper, but you get the idea. What we do to 1, we're going to have to do to everybody, like we did on the page before. Where am I going next? Well, in this first column, we always work by columns. And don't worry, this section 8.1 is homework due tomorrow. Whew, so we have another day to practice and work on it. And actually, I'm hoping only half a day, we can move on. But this is building a foundation for all of Chapter 8 and systematic approaches to dealing with matrices, okay? So hang in there. But do you notice in column 1, we got the 1 first, and we're able to use the 1 to multiply by the opposite to eliminate, to get the 0? We're going to do the exact same thing in column 2, but here's my question. Where do we get the 1 or establish the 1? Does it go in the same row? No. Where do I need the 1? I'm going to establish him there. Which means I'm not going to touch this first row. And if you guys look at our last example, I didn't touch the first row once I had him established. So now we're going to go aiming. We aim to get a 1. We aim to get a 0. Now we aim to get a 1, which will help us get the 0. There's a system that can be programmed where your calculator has been programmed. Yeah? Now hold on, what's going to happen in order to get this 1? Yeah, aren't we going to have to do 1 over? Ugh. Why am I not putting a number? It's going to be a mess. Now, Adam said C. Well, sadly, I'm already using C. But couldn't we just kind of do like a little D down here and be like, whoever he's going to be, and then maybe a little E down here, whoever he's going to be? It's going to be 1 over D. Once again, I don't want you memorizing this stuff. Yeah? But whoever in the E spot, divide by D, but D over D will get 1. It's okay. If you guys pick up a higher math book and try to open it and look at it, they're not able to do kind of messy explanation like this. They do it very technical, and so you're like, oh, that's heavy. But it's because they have to do, formulas get harder and harder the more complicated they are as far as explaining everything going on. So we're just getting the idea. Once again, I don't want you to memorize, but do you guys see how we're aiming for? We're aiming for next to get to REF, where we want the identity. We like that. We like that. We need a 0 right here. Do you see it? If we can get there, are we golden? Oh, yeah. Because we'll have 1x equals 1y equals, we're done. And some of you just realized, this is just to solve for x and y? Couldn't we have done substitution? Kim's laughing because she sees it. Couldn't we have just done elimination? Couldn't we have forgotten the whole matrix thing? But wait, what do you think is the simplest RREF do? A 2-variable 2 equation. What's harder? A 3x3, a 4x4, a 5x5. Remember that awful one from yesterday? How do you understand how to program some cool machine to do the work for you? Start at the beginning and be like, okay, how can I break this down into steps? And whatever steps gets us an identity in a 2x2, maybe we can use for a 3x3, 4x4, 5x5. How do I get a 0? You have a 1 right here? By the opposite of him and add? And actually, I can show that because that one wasn't too messy. So I can do a negative a12 over a11 times r2 plus r1. As soon as we get 1s, we can just multiply them by the opposite and add. We could have a computer do that for us too. And when we're done, I'm just going to cheat a little bit. We'll have our x and we'll have our y. Is that okay? And some of you are like, what on earth did she just write down? Let's see if we can at least start an example to end class today. Sound good? Ugh. Hang in there, Jason. Whoo! How big is he? It's a 4x4? We're supposed to be able to, maybe we should rearrange these. Does that sound good? Okay. Let's go get the easy one, and maybe we'll save the hard one for the beginning of class tomorrow. Cool? Wisdom teeth. Don't lose all your wisdom tomorrow, Kyle. Here we go. Okay, let's do a nice one. Wait a minute. This one's at number 65 in homework? All right. Well, or something weird's going to happen with this one. Can I make this into a matrix with 1, 2, 2, 1, 7, 8? Are we good? Who remembers the name of this matrix when we take a system and put it into a matrix? Augmented. Dotted, solid line, I don't care. Just separate. What's the first step? Get a, oh, that's nice. It's already there. But guys, if you had told a computer to do 1 over who's there, 1 over 1, would I still have my 1? Okay, anyway, I'm already good with that guy. I'm not a computer. Extra work. Let's keep going. Now what do I want to get? Remember, he's good. He's good. We leave him. Whoever he is, he's good. But how do I get a 0? Good. Multiply R1 by the opposite. Who's the opposite of 2? Make sense? Multiply the top, where the established 1 is, by the opposite of the bottom. So what's negative 2 plus 2? 0. What's negative 4? Negative 2 times 2. Plus 1? Negative 3. What's negative 14 plus 8? Some of my mental mathers, you're going to have fun with this. What's the next step? Leave the first. Adam just said divide. Why? Because we want to get a 1. 0 divided by anything. Negative 3 divided by negative 3. Negative 6 divided by negative 3. Row echelon form says stop. Reduced row echelon form says no, keep going. Because all we have to do, thanks for the enthusiasm, Kyle, is get a 0. How do we do it? Adding by the opposite. R1. Don't worry, anything times 0 is 0. Plus, I'll still have my 1. Negative 2 plus 2, start packing. Negative 4 plus 7. X equals 3 when y equals 2. Guess what changes when we have a much bigger one? Not much. We get a 1, zeros. 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 We'll see it tomorrow. Bye, cool kids. See you later. Start homework. You might not be able to get all the way, but you can get somewhere. Bye, guys. Happy Valentine's Day. No homework fully done until Tuesday, but get that puppy started.